Hi everyone, these are the notes on naming molecular compounds. You should have a periodic table in front of you as well as a copy of these notes. If you for some reason cannot find a paper copy, there is an online copy on Canvas. So molecular compounds I find are the easier compound to name. So they use prefixes to describe the number of atoms in a molecule, which means instead of having to look at charges and do the math and figure out how many of each, you literally just have to either know the prefix to make the name or be able to read the prefix from the name and transfer it as a number. So here's the list of the prefixes that we are going to have. One is mono, two is di, three is tri, four is tetra, five is penta. A lot of times people like to mix up penta with the prefix for seven. One way to remember penta, think of the pentagon. Okay, it's called the pentagon because there's 5 sides. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Now, we very rarely ever go past, we'll use hepta. We don't really use nona and deca, but they might come up, which is why I'm telling you about them. So each element in the formula is assigned a prefix. However, there's one really big exception. If the first element, so the element that appears first, only has one atom, it does not receive the prefix. We never, ever, ever start a molecular compound with mono. That's just the rules, okay? And similar to ionic compounds, the ending of the second element is changed to IDE, so you should be familiar with doing that already. All right, so we're going to go through an example together with CO2, okay? So the first element is carbon. It does not receive a prefix because I only have one atom, okay? One atom. All right? The second element always receives a prefix. So I have 2 oxygen, so I'm going to use the prefix di, and oxygen becomes oxide. So carbon dioxide. Okay. Now I want you to pause the video and I want you to try this practice by yourself. So go ahead, pause the video, come back when you're done. All right, welcome back. Hopefully you completed this table. I have already done it, so go ahead, pause the video, check your work. One thing that I think is really important to point out is when we're putting the two together, I do know I didn't leave a lot of room, so sorry for that. But one thing that's really important to notice is that when we are working with a prefix that ends in a vowel and a non-metal element that starts with a vowel, okay? So mono and oxide are very good examples. We cannot just smush them together because that would end up with, it would be like monoxide, okay? That we can't do that, all right? So you'll see in my answers, I have only left one O for the monoxide, okay? we can have an I and an O next to each other, so that's why I left the I. So nitrogen dioxide. And then A's next to O's are also a little weird. So instead of trinitrogen tetraoxide, it's trinitrogen tetroxide. Oxygen is really the only one where we have to worry about vowels. Again, I know I'm not an English teacher. However, these spelling issues are very important to get right. So when we are correcting things, it is important that you have it spelled the way I have here, or else it's going to be marked incorrect. Okay. All right, now we are going to go over how to find the subscripts based off the name, and it's very easy. Okay. The prefix tells us the subscript of the element. Okay. It's that simple. So in this example that we have here, we have dichlorine heptoxide. So di means two, so I have two chlorines. Hepta, okay, and remember we have that oxygen, so we have to get rid of that A. Hept means seven, so I have 7 oxygens, and I just put them together. Charges are not important for molecular compounds, okay? If you are worried about charges and you're naming a molecular compound, which means 2 nonmetals, you are not going to find an answer, okay? So charges are not important when naming molecular compounds. They are only important for ionic compounds. Now, I want to bring your attention to this naming flowchart at the bottom of your notes. It is not printed well, okay? I promise you will get another kind of class handout. I also have a PDF copy on Canvas in the references module. So this flowchart is the strategy for mixed naming, okay? And one of your practice worksheets is mixed naming. So it's really important you know how to read this flowchart. First question, is there a metal in the compound, okay? If there's a metal, there's going to be ionic naming, all right? If the metal's a transition metal, okay, that means that there is going to be Roman numerals, all right? If there's no transition metal, no Roman numerals, okay? When you see these words binary and ternary, okay, binary means that there's 2 elements, okay? Ternary means 3 or more elements. So that means we have polyatomics. There's also a list of polyatomics included on this sheet. But again, you will have your periodic table that also has a list on the back of it. All right, so that's for ionic naming. We've talked a lot about this. Next, we're going to look at what if there is no metal in the compound. What does that mean? Okay. If there is no metal in the compound, you have to be very careful with what the first element is. If the first element is hydrogen, that means it's an acid, okay? Because if you just say, oh, are there 2 nonmetals? Well, if the first element's hydrogen, yes, there are 2 nonmetals, but hydrogen being first makes it an acid. So that has the special rules. If the first element is not hydrogen, okay, that means it's a molecular compound, so you are going to follow the naming rules that we have gone over today, okay? One thing I want to point out is what to do with H2O, okay? H2O, its first element is hydrogen. However, water it has to do with acids and bases. Water is the middle. It's not an acid and it's not a base, okay? So water, even though it starts with hydrogen, it is a molecular compound. We name it like a molecular compound, okay? So you're going to follow the left, a really bad arrow. You're going to follow the left, the no side, okay? And you're going to name it how you would a molecular compound. Do not name it like an acid. It's not going to work. But a lot of people kind of get mixed up with that, with water. All right, so that is the end of this screencast. There is a practice worksheet for you to complete. One side is just molecular compounds, naming and writing the formulas. The other side is a mix of acids, ionics, molecular compounds.